At long last, we can finally talk about the key class methods that are part of ConditionObject. As you'll see, there's a bunch of methods. Some of them are not widely used. Several of them are very widely used. So we'll focus on all of them, but we'll focus first on the ones that are most common. So remember, the whole point of this abstraction is to allow threads to coordinate their interactions by allowing them to wait and notify on each other. And so it may come as no surprise that the key methods that we have are ones that are used to wait and ones that are used to notify, although they don't have the words wait and notify for reasons we'll talk about in just a second. These method names, await versus wait, and signal versus notify, and SignalAll versus notifyAll, are similar to the names that are in the Java built-in monitor object methods, wait, notify, notifyAll. But they're different, and the reason they're different is that because everything inherently implements class object, or the object class, which is the root of all classes in Java, and those already have wait, notify, and notifyAll methods in them, and because those wait, notify, and notifyAll methods that are in Java object are defined as final, they can't be overridden. So they had to invent new names, which turns out to be very complicated and confusing. And invariably, you will get confused and use wait where you should use await, or notify where you should use notify or signal, and notifyAll where you should use SignalAll, and so on. And there's no way for the compiler to stop you from doing those things because those other methods are already baked into the API of every object, which is confusing. Under the hood, these methods are implemented using the abstract queued synchronizer framework. So await basically calls into the queued synchronizer framework to do its thing, and SignalAll. And they're very, very powerful, very complicated implementations, which we will not walk through in detail at the moment, but it's cool to look at the source code. So let's talk about these methods. We'll start with the first one, await, which signals the calling thread, await suspends the calling thread until it's signaled or until it's interrupted. So await is very much like wait, except it's on a condition object, not on a built-in monitor object. And what happens when you call await is that basically causes the calling thread to be parked on the queue or the wait set inside the condition object. So it just moves the thread and sticks it at the end of a queue. When signal is called, when one thread signals a condition object, it takes the longest waiting thread from the queue. So remember, we had this queue. Here's the longest waiting one. And we take that thread and we move it to the queue for the owning lock. Remember, condition objects always used with a reentrant lock. So it goes from here and moves at the end of the queue of the owning lock. So that's what signal does. So that says, now you get a chance to run when you can acquire the lock. And then SignalAll moves all the threads from the condition object's queue to the owning lock's queue. So it goes here. Everybody shows up in this queue. And I should also mention that where you go in this queue depends on whether or not this lock is in fair or non-fair sync semantics. So if it's in fair sync semantics, you move to the end. If it's non-fair sync semantics, you could barge ahead. But the main difference between signal and SignalAll is shown visually here. Signal moves one thread. SignalAll moves them all. Now, one of the consequences of SignalAll is it can lead to this thing called the thundering herd problem, where everybody shows up. Now, this is fine if you're trying to do something where all the threads need to be awakened in order to do something. Like, for example, when you're going to shut down some kind of thread pool and you want all the threads to wake up to realize they all need to terminate themselves, SignalAll makes perfect sense because they all have a reason to be awake. Conversely, if you're going to put one item on a queue, you really don't want to wake everybody up because they're not all going to get that one item. Only the first thread's going to get that one item. So use SignalAll very sparingly. You should only use it if there is indeed something that all the threads need to be awake to do, to check some condition, for example, to shut themselves down. Or if you've just given back a whole pile of elements, you should wake everybody up because they might actually get something. So use SignalAll very sparingly, otherwise you have the thundering herd problem. There are other methods on ConditionObject besides just await, signal, and SignalAll. There's a pile of different await methods. So for example, this is the one we just looked at. There's also these. This one is a timed await. This one is a timed await using nanoseconds as opposed to microseconds, milliseconds, or seconds. This one will force the calling thread to wait until it's signaled and it cannot be interrupted. So by default, you can be interrupted, but if you use await uninterruptibly, you cannot be interrupted. And then await until basically waits until some deadline in the future. So it's more of an absolute calendar time than some relative time relative to now. Interestingly enough, Java's built-in monitor objects also have timeouts on their wait method, but there is no return value. So it's next to impossible to figure out why a timed wait call returned on a built-in monitor object, because you have no idea, did it time out? Did it actually get signaled? You don't know, which is really, really weird. And so you can look here for some tips on how to deal with this. The best way, my best tip for how to deal with this is don't use built-in monitor objects to wait and notify threads, but instead use condition objects because they don't have these silly problems.